Hello and welcome to the Bearded Math Man's YouTube channel. Hey, I was wondering the other day why the square root of I is equal to the square root of 2 divided by 2 plus the square root of 2 divided by 2i. Boy, it's really confusing. See, I was doing a math problem and I came up with the square root of I as a solution. So I wasn't really sure what that was. I had forgotten. So I went to our good old friend GOOGLE and I typed in, hey, what's the square root of I? And it told me that it's 0.707 and plus 0.707i. Well, I remember that's the square root of 2 over 2 and the square root of 2 over 2i. So is it true that the square root of I is equal to the square root of 2 over 2 plus the square root of 2 over 2i? That seems kind of strange. Is it true? And if it's true, how did somebody figure that out? So that's what we're going to talk about in this video. So let's start off first of all with whether or not this is true. And after we figure out if it is true, we'll see if we can figure out how you could come up with that answer algebraically, right? Now, first of all, square roots, the square root of 1 is equal to 1 because 1 squared equals 1. So the square root of a radicand equals another number if that number squared equals the radicand. So if I square this whole thing right here and I get I, then it's good. So let's try that, right? Let's square both sides, see what happens. Square root of I squared is I, of course, right? But this is where we're going to get a little tricky. So the square root of 2 divided by 2 plus square root of 2 divided by 2i squared. Let's go ahead and see how that works. Now, squared means the base times itself. Everything in the parentheses is the base, right? And if you remember, this is a binomial times a binomial. We could use FOIL, but let's be a little careful here. So what this really means is everything, this first term times everything in the second group, and then plus the second term times everything in this group. So it's going to look like this. Do you see? First term times the second group plus the second term times the second group. Yeah. Now, one last thing we got to remember, when we multiply square root of 2 times the square root of 2, well, that's going to be a little ugly, you see? So square root of 2 over 2 squared is the square root of 4 over 4. Square root of 4 is 2. 2 divided by 4 is 1/2, right? So let's go ahead and just be careful with this. Square root of 2 over 2 times itself is just 1/2. And then the square root of 2 over 2 times square root of 2 over 2i is plus 1/2i. Yeah? So the same thing's going to happen over here. We're going to get 1/2i, and then we're going to get 1/2i squared. Do you see? So square root of 2 over 2 times square root of 2 over 2, when they're both i's, you get I squared. Now, of course, I squared equals -1. So that's really -1. -1 times 1/2, -1/2. Do you see? Now, we can simplify this a little bit. 1/2 and the -1/2, those make 0. And I'm not very good at math, but I think 1/2 plus 1/2 is 1. So it worked out just perfect. The square root of 2 divided by 2 plus the square root of 2 divided by 2i, that whole thing squared, just equals I. Huh. That is crazy. So now let's see if we can figure out how it comes to be, where it comes from, why it's true. Let's see if we can figure out algebraically what the square root of I really equals. So a good place to start is just start with what you know. We know that the square root of I is imaginary, and if it's imaginary, it can be written as a complex number, where the real part's first, the imaginary part's second, right? So let's go ahead and just do some math, see if we can stumble across something. What if we squared both sides? We end up with this, do you see? We could actually start doing something with I equals the quantity a plus bi squared. Square both sides, perfectly legal. So let's go ahead and explore this a little bit, shall we? Now, a plus bi squared. Now, when we square that, need to be careful. Let's go ahead and write it out right here. We're going to get, the first term times the second group plus the second term times the second group, like this. Distribute, combine like terms. Be careful that you're squaring everything that needs to be squared. Here's what we have. A squared plus 2abi minus b squared. So when you square a plus bi squared, this is what you get, right? Now, let's go ahead and rewrite that is a complex number. So these parts are real, and this part's imaginary. So this is the real part, this is the imaginary part. So I is a complex number. It's 0 plus 1i is equal to a squared minus b squared plus 2abi. Do you see? So 0 plus 1i, there we go. Now here's why we did that. You see, this is the real part of I, and this is the real part. So these two things are real, and these other two parts, well, those are imaginary. So in order for this to really be equal, for this to be true, the real parts have to be equal, and the imaginary parts have to be equal. So our real part is 0 equals a squared minus b squared, and our imaginary part is just I equals 2abi. That's our real and imaginary parts. So let's go ahead and see if we can do this right here. We actually have a system of equations now. Do you see? We have two equations with two variables. We can use substitution. Substitution's pretty nice. So let's go ahead and use this right here. Let's go ahead and simplify this. And let's go ahead and end up solving for b. So we divide both sides by 2a. We know what b equals now. Do you see? Now, this is a difference of squares. We could substitute right now, but it's a difference of squares. If we want to solve it, we can factor it, and that makes life a little easier, right? All right, now let's go ahead and substitute. We know that b is equal to 1 over 2a. So we're going to substitute both b's with 1 over 2a. Now, we have it factored. We're going to take each factor, set each factor equal to 0, right? And then we're going to solve. Now, to solve this, we need to get a common denominator. So we're going to multiply this by 2a over 2a. Same here, 2a over 2a. And then what we're going to end up with is 2a squared plus 1 over 2a and 2a squared minus 1 over 2a. Multiply both sides by the denominator. 2a times 0 is 0. And when you multiply this side by 2a, the denominators go away. So there you go. Now, let's go ahead and solve these with inverse operations. We're going to subtract 1 for this first equation. We're going to add 1 for this one. There we go. Divide both sides by 2. Here we are. Now, next up, to get a by itself, we've got to take the square root. So check this out now. If you remember, we're dealing with the real portion. So this part isn't a valid answer because we're dealing with the real portion of this number right here. So we need a real answer. So we only have to worry about the positive square root. So the square root of 1 over the square root of 2 is what a equals. Simplify it by rationalizing the denominator. Square root of 2 over 2 is what a equals. All right, now let's use that to figure out what b is. So a is equal to the square root of 2 over 2. We substitute it. When you reduce this, you're left with 1 over the square root of 2. And we just saw that when you rationalize the denominator, you get the square root of 2 over 2. So the square root of I is equal to a plus bi. We just found out that a equals the square root of 2 over 2, right? We also found out that b equals the square root of 2 over 2. So we just used algebra and a system of equations to figure out that the square root of I is equal to the square root of 2 over 2 plus the square root of 2 over 2i. So let's put this all together now, shall we? Let's go ahead and back up. We started off with, hey, wondering, what is the square root of I? Looked it up. The computer told us it was this fancy, ugly, complex number right here, right? So we verified it. We squared it and saw that I does, in fact, equal the square root of 2 over 2 plus the square root of 2 over 2i squared. So that's valid. That's true. So then we wanted to figure out, well, can we come up with this number? Can we come up with that the square root of I equals this? So what we did is we started off with a simple equation. We knew the square root of I was a complex number. So we went ahead and squared it, right? And we went ahead and the real part of this complex number is 0, simplified it, and then we went ahead and set up a system of equations and did some substitution. Now, we didn't do the substitution quite like this. When we did it just a minute ago, we ended up factoring this difference of squares, but you can get the same answer if you don't. So I substituted in here, get a common denominator, you end up with the fourth root of 1/4. That does simplify. If you rewrite these as exponents, you can see 2 times 1/4 is 1/2 square root. That's the same as an exponent of 1/2. 1 over the square root of 2 is square root of 2 divided by 2. And then you substitute that in right here for a, get the same thing. So, kind of an interesting exploration. I hope it's been enlightening and maybe even kind of entertaining. If it has, and if you're interested in learning more about math, you can visit my website, beardedmathman.com. I am posting all kinds of material, free for students and parents and teachers. All you got to do is go see what class you're looking for. If you're a teacher, you can peruse and find all kinds of lessons, assignments, quizzes, all kinds of good stuff. If you're a student, you can find all kinds of resources to help you out with whatever it is you might be stuck with. I hope it's been helpful. If it has, hey, give me a thumbs up. Consider subscribing, share it on social media. Until next time, I hope you guys are having a wonderful day.